Hello and welcome to the Database YouTube channel. Today we will talk about window functions. In the next video we will code some examples in BigQuery, but before we will look into a Google Sheet to explain what are window functions and which kind of window functions are available. Window functions are quite complex at the beginning, but they are super powerful and useful as well. So take your time to understand the topic in combination with the upcoming video. But before you watch this video, please check out the other videos from our free SQL course on this YouTube channel. Or go to our website, link in the description, and watch the videos there. But let's start with the window functions now. So this is our Google Sheet where we will at the end now describe the most important window functions we have in BigQuery, what are they in general are capable of and why they are super useful to solve certain problems. So this sheet here, the employee sales, is just our starting point with the data we will work doing this video. You know that maybe already because in the previous video we already talked about how to connect BigQuery with a Google Sheet, because then for the upcoming video we need exactly this data inside BigQuery to write the corresponding SQL scripts to achieve the same results as in the Google Sheet. So due to that, let's quickly check it again. So we have the date with already formatted nicely dates like in BigQuery. We have the employee name, we have the region, and we have the sales. So 4 different regions, a lot of different employee names, and then just a metric. So the first one is the rank. And I think when you already understand that, and also especially what window functions are, we have made a super big step in understanding window functions, because then at the end it's just knowing which different functionalities or which different calls, SQL statements you have to use window functions at the end. So we have again our employees, we have again the region, and we have again the sales. We just now get rid of the date because for this example it's not important. So, and for the window functions, you always have 2 important parameters you need to think about how to build your window function. It's the partition and it's the order. None of them is mandatory. They can be added, yes, but that's it. So when you leave the partition, you are getting a complete different result than when you're adding one, and the same for the order for sure, but both have different things they are basically handling then at the end in the window function. So we have the partition region. So always partition colon region means the region is the column, and this solves the functionality or has the functionality of the partition. And the order is the sales. So what does that mean? Descending, just as a quick important information. So what does that mean? Let's handle at first the partition. We have the partition region for the sales rank, for the sales dance rank, and for the sales row number. These are just already different window functions at the end. So we have the rank, we have the dance rank, and we have the row number. All of them at the end handle the same kind of functionality at the end, but they're working a little bit different in terms, you need to decide at the end which functionality you need or what fits at best your needs. But let's handle at first the region. So the region means every different region, so here for example East, is a single partition. So let's maybe put that into a color. So here we have, maybe a bit more, or we put it in yellow. Let's see. So I think that is easy to see. So then we have North, so that's the second partition. Completely unimportant from the East region. It's a single block of data at the end. In this case, for our row number, for our rank, and for the dance rank. Then we have the South. I will just again with the other 2. So I will also put these 2 yellow. So and then we have again the West. So this one. So and now we can check what's going on here. So we have the KC East sales 200, which is the sales rank 6, sales dance rank 5, and the sales row number 6. So as you see, we are order by the sales descending. What we also did basically in the ordering of the data itself. So you see that it's here going down. And you see that the amount always, as you see here, in the partition has the highest value. So 6, 9, 6, and 6. And in the partition itself, you do not find a value which has that high amount for that column for sure. So what it does, it's saying, okay, please check at first the first partition, the first region, so East. And then please order the rows I have in that partition based on the sales which was made, but descending. This is what it's basically doing here. And then we have all the different window functions already at the end. We have the rank. The rank is doing it that it say, okay, the least one based on the order gets the number 1. So yeah, or in that case, because it's the descending, so it's even the highest one, better to say. So here the highest row with the highest sale in that partition gets the sales rank 1. And the second highest one gets the number 2. And the least one, so Casey in East, on any particular date, not important here, the sales are just 200, has the sales rank 6. And that's it. So now inside this partition, we basically just ordering them. In the next partition in North, it's doing exactly the same thing, completely unimportant what happened in the East region. So we're checking again. Bob had the highest amount of sales and also Jane. Due to that, and that you also see here and here, the rank is doing it that it's because it's the order sales are for these two exactly the same due to that both gets the 1 order inside, right? So both have the same value due to that both getting a 1. The Jane gets the 3, so it skips the 2. Why? Because we have 2 1 ranks inside. Then for the 4 again, we have 2 times the 300, so 2 times 4. And then again jumps over the 5 and already taking the 6. And that's it basically. So that it's doing for South and for West also. Then we have the dance rank. The dance rank works nearly exactly like the rank, but for sure not exactly like, because then it would not make sense to make a new function. The only thing what is changing is for the dance rank is exactly that one. So when you have upfront inside your partition 2 times the same number as you see here and also in column D, the dance rank does not skip the next number, the rank skips the next number, or skips as how often you have multiple times the same rank before. I think that's how you can explain it. Which means here you have 3, 3, 5, because so the 4 is missing because you have 2 times the 3. In the dance rank, you have still 2 times the 3. It doesn't skip any number, so then it continues with the 4. And here it depends completely which use case you need. I already needed all of the 3, even also the row number I needed for certain cases. So that totally depends on the use case. But just you need to know all of the 3 possibilities are there. And the row number is even easier, so it never gives the 1 twice. So here you see 3, 350, 350. So here it says 3 and 4. Here it says 3, 3. In theory, there's, for example, also a date next to it, right? And then it's random which date, so which row at the end, gets the 3 and gets the 4 when both sales are here the same. For the same region as well, for sure, so inside the partition. Also, that's super important because it can be that you basically, for example, need to assure that you do not have duplicates in your data. And then you can say, okay, I do not want to have duplicates inside, so I want to have here every column to have a single row. And this you can, for example, achieve with the row number. Here you see, for example, so we just ordered by the sales, but here, for example, then the row number 1 here, and then comes to 2. But that is just depending because in the SQL statement in BigQuery, we just said, okay, please order by region and then by sales descending. And the order by of the whole table sorted it differently than the order in the row number. As I said, it's random. So due to that, again, here you also have this jump. This is something which could happen. If we would order it for sure also based on the row number, that it would not happen anymore. So that's the rank. And when you understood especially this whole partition and order thing, you already get most of the idea of window functions. So it is basically to categorize your data and based on that, making further changes. You can also say certain rows here are depending on other rows, right? Because window functions at the end is maybe apart from joins, maybe that's a little bit different because you can also basically do everything you can do with window functions, or nearly everything, I think everything. You can also do with a join, which also other data warehouses or other operative databases where you do not have window functions, you need to use joins at the end to make this happen. If you do not know what joins are, check out our YouTube channel. There we have a video already about joins. Window functions are at the end the only one with maybe joins to say the result of the row is depending on the other rows of the same partition. And that's it basically. So let's check out what else we have. We have the sum partition by date. So here we have now again the date, we have the employee, and we have the total sales, and we have the running total. What does that mean? We said now the partition is the employee, so for sure we also ordered it like that. So that one is one partition. Casey is a partition, David is a partition, and so on. I do not mark now all of them yellow. but I think the idea is clear. We ordered it here also based on the date and also in a window function. We ordered it by date. And now we see, so let's check the first example. We have the total sales of 300, again of 300, and then 671 in that one partition. And now we say we want to sum up the total sales partitioned by employee, order it by the dates. So due to that, you have your running total, which means, let's say first day, Bob 300 sales. After the second day, basically Bob has the metric now, not that he made in total 300 sales again, he made in total 6. So at the end, the sum of these two. The next day, Bob made 671 sales, and then he has now a total of 1,271, which means it's the total of these three. So it's adding always this plus this is this, and the order is made based on the order you gave here, the date, and the partition is for sure always. So for the next one, for Casey, it starts again, the 200 here, because on the first day, on the 9th of August, the sales are 200. Then 854, because you have 200 plus 654. And that's it. And that is basically doing the same thing for all the, I think, quite easy to understand. So then let's do the next one. Here with an order by, already a little bit more complex. Or not more complex, but it's more special. So what we have is, in that case, that we have again a sum, but here we do not have a rolling sum. We have a rolling sum, but we left the partition, which means even that we can do. So we can also say, okay, we do a window functions, but as I said, they are not mandatory. Due to that, we said partition, there is no partition. And when there's no partition, you can also say the whole table is one partition. So all of that is basically interesting for the same window function. It's never starting again at the end for the same table. And now what it's doing is we are just saying, okay, order by date. So it's the same kind of thing also with cumulative sales and so on. So the same window functions as we used in the example before, but it's working a little bit different by that it's saying, okay, we have now here a lot of time the same date inside. So due to that, it sums up all these ones here. And we have 3,646, which you exactly see here. The sale metric for Bob is 300, and in total for that date, we have 3,646 sales. Important, for example, if you want to see, okay, you know at the end your sales metric on this day is 3,646, but what every employee did or contributed on that sale, you can just easily by now basically dividing this by that, and then you have your weight, and at the end you have then again for this date 100% of your sales, but you know how big was the weight for Bob, for Casey, for David, and so on and so on. So and then for the next one, for the next date, so for this one again, so 4,197 plus the 3,646, because it's still a cumulative sum, and due to that, because we order it by the date, and due to that, for all these rows, for the 10th of August, we have 7,843. Yes, and then we have Bob and so on, Casey, David again for the 11th of August, adding them again, plus this is this. That's it. Yes. Then the next one is the count. Also, I think super easy. So here we have the other way around. We have a partition, but we do not have an order. Which means we have the partition, let's maybe mark them again. Here we have the partition east and we have the partition west. And then we have south, yes. And what it's here doing, it's counting the numbers of employees. Count distinct. We already know count distinct, else what in our YouTube channel, there we have already a video about aggregation methods in BigQuery, and there's the count distinct inside. So we have the numbers of employees. So here it basically just has two. What is it doing? So it's taking the partition region, so that one, and then you are just doing a count distinct of the employees. Casey and David, number of employees 2, for all these, all of this partition at the end. For north the same, Bob and Jane. For west, Eve and Frank. And for south, we have 3 employees. So we have Ivy, Hank, and Grace. And for sure, you can here always also add the sales, the date, and so on. You can always put here, due to that we have here Ivy 3 times inside, because she has sales on 3 different dates, but not important in our case. Due to that, just focus on the most important part, but you can always add for sure all the columns you need. Then we have 2 more or 3 more. We have the lead and the lag functionality. So the lead and the lag takes the data from the last value, so from the previous value, or from the next value, depending on lag or lead at the end. So let's check. So we have again partition region. So these are our regions. These are the employees, and the order is by sales. Due to that, we ordered at the end the table based on sales. So the previous sales is checking the value based on partition region. So this partition based on order sales. So checking, okay, when we order this one, is there a row which has less than 200 sales? For that partition, no, not for the region itself. Due to that, the previous sales is null at the end, or empty, however you want to say. In BigQuery it would be null. But the next sales, so the 300 is there. So due to that, because Grace and then at the end, again, did 300 sales. So due to that, the next sales is 300. And here it does again. So for the 11th of August, Grace in South did 300 sales. So checking, okay, what were the previous sale at the end based on the rows by the sales. Then you have 200. And the next sales are 345. I think quite easy to understand. For sure, then on the last row, you have Hank with 654. You have here in the previous sales again 654 because also Ivy did 654 sales. But there is no next sales, and due to that, that's empty. And this, as you see, so you always see that pattern, empty, empty, beginning and ending of the partition. And you see that here you always have this gap here and here, here and here, because it's always a previous and a next value at the end. So let's do, we have, the next one is first and last value. So here again, partition region. So let's do our usual thing. Yes, now we have first partition again. We have the sales in East. We order it again by the sales. And now we just would like to know, okay, what are the first sale? So the first sale in this case is, because we order it by the sales, so it's 200. For all the rows inside that partition, the first sale is 200. For that partition, row with the least sales, you can say 200 and 220. And here you see something which is interesting. It's it's last sales, so it's the last value. And here you see, okay, what's going on here? You would, when you basically understand it, you would say, wait, why is it not always 654? Because at the end, it's just, so we do not want to have the first value, we want to have the last value. You can tweak the last value like that. To be honest, with that last value functionality, we also didn't see it in BigQuery. I just would like to show you that the last value works differently, also in terms of when you need to program it or coding it at the end, works differently than a first value. Due to that, you have here basically 200, 344, 5, 345, 350, 350. So basically it's always the same as the sales itself. So you have two possibilities. You can add, you will see it then in the next video in BigQuery. You need to put another certain method inside that your last value is working as anticipated, so as you like. Or you just do it the other way around. You're taking the first value, but not order it by sales, order it by sales descending. Super easy. Because then basically your whole partition gets swapped one time, and then you have the 654. So basically when you're just thinking about it at the top, and then your first sale based on that is the 654. That's how I am usually doing it. So I never use last value, at least not for this case. And then I'm just deciding, okay, do I need to descending the order or should be the order ascending? Yes, so due to that you see this weird behavior, but more than in the upcoming video in BigQuery. And then we have the next one that's just more mathematical, because you also have different mathematical functionalities. So for example, here you have the standard deviation inside. And again, here I forgot, sorry, to add the partition value, but it's again partitioned by region. So we have north, south, and west. Here it's basically just calculating from all the sales you have in the region east. It's calculating the standard deviation. You already see when you look at more and more window functions and on the data more and more, you see quite quickly, okay, for these ones, they're always the same. Due to that, they need to be inside the same region. Quite easy here also to see them. Now you got basically first look into the most important BigQuery window functions. Now you have an overview of window functions and their capabilities. In the next video, we will go into BigQuery to find out how to write these SQL statements to achieve the same result as in the Google Sheet. But that's it. If you want to have more information about SQL in general, you can check out our blogs on Medium, posts on LinkedIn, and our website.